it's important to make a distinction or define even virtualization. So in my mind, it's an overloaded term, one that gets used and thrown about in general ways. So there can be some confusion there. Virtualization just refers to taking previous hardware-based software that required specific hardware, virtualizing it and putting it into a purely software component. So in the early days of network switching, it was very hardware-based, but then it moved to being software-based that allowed for much faster network switching. And now much of the software that runs in the cloud that does all the networking is actually no longer hardware-based, it's software-based, so it's virtualized. So let's establish that first. Then there's two places you can really virtualize. There's at the ground site, and then there's in the cloud, right? At the ground site, you can virtualize a lot of the processes into software-based modems. So take, for instance, Emergent and Kratos. They both have software-based modems that can be run on commodity hardware. So you might spin up a Dell server and run this software in a virtual environment, which could be its own operating system within the Dell server. You can have many operating systems. I won't get into too many details there, but the virtualization refers to it just living within a commodity piece of hardware like a Dell server. And you could have many different versions of a modem living within this and in this cluster of many different pieces of software. So that virtualization can happen at the ground site to process data before it's backhauled, perhaps strip out different things like fill frames or reduce the burden on the network. So you might want to strip away as much of the data as possible that isn't required and then upload it to the cloud, okay? And you might want to do that because you have a very low-speed data backbone at the ground site. Let's say you're in some very difficult location that only gets 100 megabits per second. And to get a higher data rate is extremely expensive. So you would do this at the ground site, but you can do it in a virtualized way. So then in the cloud, nearly everything is virtualized. Virtualized in the sense that you are running an isolated application, running on some Amazon or Microsoft server somewhere, and that application accepts the data in some way, gets triggered to accept the data that comes from the ground site and makes it to the cloud, and it's further processed or dealt with. So virtualization can occur at the ground site and in the cloud, and one of those we would call edge computing. So it'd be virtualized at the ground site, and it's at the edge, meaning it is at the location where it's discovered or downlinked. So you have virtualization at the edge, and then you have virtualization in the cloud. And in the cloud, obviously, you have a much larger ecosystem to deal with that data. You have, at this point, I don't know how many services, but hundreds of services that you can leverage in the cloud virtually much easier than you could at the ground site. Because at the ground site, to leverage all of the services that exist in the cloud is very expensive and not necessarily even possible at this point. So what you want to avoid doing, in my opinion, is processing at the ground site. We want to shift as much to the cloud as possible, where the ecosystem for doing the work that we desire to do is much larger. You have more options and it's cheaper. Anytime you start talking about putting equipment at the ground site, that's an expense, that's maintenance, etc. And it costs more. Now, there are good reasons to do virtualization at the ground site. And that can be, as I cited before, it can have to do with the bandwidth to the cloud, and that's one of the main drivers. It can also have to do with the cost of the hardware that you put at the ground site. So it depends question. And what is the problem that you're trying to solve, and what are your limitations? So virtualization is a beautiful thing. It's been going on for a long time, and I think it's a little bit overloaded of a term, but it is and has revolutionized many industries. Well, the main cost, again, goes back to something I've been talking about in my earlier answers, is the cost of what might be a software team or network engineer, potentially development operations engineers. So the cost isn't small. It's at least 3 full-time people. So there's that cost. The other cost would also be the hardware that might need to go at the ground site to do the virtualization at the ground site, or the cost of leasing the equipment, not leasing, but utilizing the services that live in the cloud, which I can tell you that when Atlas first started, our our cost that in the cloud for our services that we used on Amazon was about $900 a month. And we did satellite downlinks with that. Then 6 years later, I think our bill is about $10,000 a month, but we do 4,000, I don't even know at this point, thousands of satellite downlinks per month. So for a $10,000 bill, that's not bad at all. So then what are the benefits? The benefits are really that you are participating in this larger ecosystem to expose your antennas to more customers and to provide better quality of service to each of those customers. I think that if you're a company, you desire to sustain your company and make a profit in doing so. And as I've said before, this industry is moving towards this virtualization, this cloud infrastructure, and you need to be ahead of it in order to participate. And not even ahead of it, just on it. And now is the time. Waiting another year would be too long. So the benefit really just goes back to the customer service, the quality of service, and the revenue towards the teleport operators. Yes, it does create new revenue opportunities. The virtualization aspect would create the opportunity to participate, as I've said, in the larger ecosystem. If you want to integrate with our company, we need a method to integrate with you. We need someone on your end who understands at least a little bit how the cloud works. Now, we are a managed services company, Atlas. So what we do, we have the experts and the professionals that can come to you and help you get integrated without you building a software team. But if you want to go integrate with someone else, I can't speak to how Amazon and Microsoft deal with it. But the question is, will you need a team to implement an API, etc., to integrate with them? So the participation is in the cloud is effectively a requirement. Well, the being aware of the cloud is effectively a requirement for bringing in new revenue in the next 5 years. Secondly, and I haven't seen this yet, but it is possible that by virtualizing, there may be a push in the future, not yet, towards allowing customers to run specific applications at your ground site in a virtual environment. Remember, I said you can have virtualization of the ground site. Well, a customer may decide that they need something local to the ground site that sits there and processes data. Traditionally, they would ship you a rack of equipment and you would plug in their equipment and they would receive the radio frequency data and they would process it on their own. However, in the future, it might be that the teleport operator provides the digitized RF straight into a virtualized environment, and that application was provided by the customer. So that application takes the data, the digitized RF, processes it for the customer, and then sends it to the cloud. So effectively what you've done is you've given more access to your customers to do very specific work at the ground site, and it allows you to scale quicker. So you take 10 customers. If you have 10 customers at your teleport, you might need to traditionally have 10 pieces of rack hardware equipment, whereas now you own the hardware equipment and you give them access in a virtualized environment to their data. So you take an application, a software application for them, you launch it into the virtualized environment, and they're ready to go, right? As opposed to physical, taking access or accepting physical hardware. Right off the top of my head, virtualizing operations has been around for quite some time, and we're talking about providing networked access to the equipment and monitoring that equipment. So you have open source tools like Nagios, which is a tool that is used to monitor all components within a network, and it's very, very flexible, and it can easily live in the cloud and reach down to the ground sites, extract the information it needs about status, etc., of all your equipment, and then be available in the cloud. So it's not very difficult to do. Quite often, network engineers already know what Nagios is. It's just a matter of launching it in the cloud and making it virtualized and accessible to a distributed operations center. We've been a distributed operations center our entire existence, with employees in at least 8 different states. Most of our employees are virtual and have always been virtual. So we had to provide access to our operations team in a virtual environment. So if you take that, just monitoring the network, again, is very easy. And what are some of the challenges? It's just being very procedural about the process of solving some of these issues. So when a ticket comes in that is driven by the software that monitors your network, and in this case, I'm just going to use Nagios. Nagios monitors our network. It might issue a ticket that said, hey, there's a warning, and we need as a team, and so do teleport operators, to be very procedural about what it takes to resolve those issues. The more procedural you are, and the more that you note down the solutions, you find commonalities with things that happen over and over again, and then you can start to automate these solutions to those things. I mean, I'll take a very simple example. If you see this one particular error in a log file, you learn that from your modem provider, you learn that that's a fatal error and you're going to have to restart and recycle the modem. Well, Nagios can do all of that, and it can do it all automatically. But your operations team needs to be aware of software and what software can do, and they need to be aware of following the procedures so that you can build out a playlist of all these actions that need to happen when something happens virtually. So it's really not that different from a standard network operations center. You just have to think of it as, where is the accountability? Where are the procedures? Because we're not here to speak to each other and walk over to someone's desk and walk back. That's not the way it works. You want people operating independently and automatically based on these procedures. So I think that's the biggest challenge, really, is just having a team that's disciplined and that is procedural and can work well within this virtual environment where they're not actually shaking hands, seeing each other, No water cooler talk, but plenty of time to interact for us on our daily ops calls to monitor the network.